today's classes we will discuss about the what is called as the convection and post convection and natural convection. So you know that in the convection, the heat transfer by the movement of fluid between the areas of the different temperature. Okay. So convection, it may so the conduction is also taking place here, and here uh, in the liquid and gases. Okay, in the liquid and gases, that one is a convection is a most predominant case, and the conduction is also that one is taking place, but it is a limited amount that one. Okay, and here you go to this picture. You know that one is the so convection is taking place between the liquid molecules that is, and where the conduction is to the solid is called as a predominant case. Okay, I'm requesting the participant mute yourself. Okay, the conduction, so that one is the heat transfer will be taking place through solid, so where it is a predominant, and so conduction is also taking place in the water and in the gases, but it is not much as in the case of solid. Okay. So we discuss about the radiations also. Okay, radiations, that one is the energy transfer. Okay, in the form of rays or electromagnetic waves. So particles is called as the radiation. But in the convection means conveying. Understand? Heat transfer through the fluid, liquid or gas caused by the molecular motions of the liquid or gases are called as a convection. What is the convection? The heat transfer, so energy through the fluid or liquid, or that's maybe liquid or gases caused by the molecular motions of the fluid or gases is called as the convection, that is. Okay. So there will be, suppose that means the a plate occurs, understand? Suppose there will be a plate occurs, that is. Okay. So if it is a plate here, so that means the above this plate, okay, above this plate, there will be water or any gases will be flowing. Then the heat will be transferred from the bottom of the plate to the surface temperature here. So heat will be transferred from the bottom, and the surface temperature is always greater than the fluid temperature which is flowing on the plate. Understand? So this type of the heat transfer, that one is the what is called as a convection heat transfer. Here the heat transfer from the surface of the plate to the fluid which is flowing above. So that is by the a convection method, that is. Okay. So we'll discuss about what is the convection. Okay. So we'll discuss that one. Then what are the, so next slide here. What are the governing laws of the convection? Okay. The governing law of the conduction, you know, Fourier's law is called as the governing laws of the conduction, and Stephen-Boltzmann law is called as the governing law of the radiation. So like that, the governing law means which law influences the convection, okay, or how that one is the concept of the law. So that one is the convection we can form. That is called as a governing law. Newton's law of cooling is called as the governing law of the, so what is called as the convection. What it says that, okay, heat transfer per unit surface through the convection was first described by the what is called as the Newton's law of cooling. Okay, Newton's, that one is described, that one is, so this is the heat transfer. So from the surface, heat transfer per unit surface through the convection was first described by the, that is called as the Newton's, hence it is called as the Newton's law of cooling. Okay, so what is that one is? Q is equal to, okay, that's the Q is equal to HC. HC, that is called as a heat transfer coefficient, that is called as a C A into dt here, that is. Where Q is called as the heat transfer per unit area per unit time because of the joules per second. Understand? Per unit time. A is called as the heat transfer area of the surface. That is in the heat transfer area of the surface. Subtracting the heat transfer from the bottom of the plate to the what is called as the fluid or liquid which is flowing on the what is called as a above the plate. So surface area we need to consider in the convection, that is in the meter square. So that is A is called as the heat transfer area of the surface. Okay, what is HC? HC is called as the convective heat transfer coefficient. Okay, so that one is the what is called as heat transfer, convection heat transfer, mainly depend upon that one is the what is called as what is the heat transfer coefficient. Okay, heat transfer Q is directly proportional. Understand? Heat transfer Q is directly proportional to the HC here, convective heat transfer coefficient. If the HC is more, if the HC is more, then Q rate of heat transfer in the convection is also more, that one is. Understand? Then dt is called as the temperature difference between the surface and bulk fluid. Okay. Suppose it is a plate here. Understand? Surface temperature is the Ts. Then fluid temperature is the T infinity. Difference of the surface temperature and fluid temperature is called as a temperature difference between the surface and the bulk fluid here. That means, so we can call that one as the temperature gradient here. That one is. Okay, so this is the what is called as the governing law of the convection. So Newton's law of cooling is called as a governing law of the conduction. Okay, so this one is the Q is equal to HC into A into dt, that one is. So that's what is the convection and what is the governing law of the convection. We came to know about that. Then what are the classification types of the convection? Okay, so there are two types of the convection. One is called as natural convection and other one is called as a post convection. Okay, so what is the natural convection and what is the post convection? So you come to know about that. Okay, so as you know that, so convection, so where the convection will be happening, that is. Okay, already we discussed about that is the evaporation. Understand? Condensation you discuss. Boiling. Okay, boiling also you discuss that is. Boiling is also convection because of the heat transfer, maximum heat transfer through fluid. Condensation. Condensation is also called as the so convection. Understand? Okay. So this is one of the example of the convection, condensation, and boiling, that one is. Okay. So these are the convection. Okay. So that one is the in the fluid mechanics also you discuss about the some what is called as the concept of the Reynolds number and what is the concept of the Prandtl number and what is the concept of that one is the Nusselt number and how these numbers, Reynolds numbers, where what is the significance of the Reynolds number is playing a more important in the convection. Okay, convection heat transfer coefficient. Okay, convection heat transfer, the Reynolds number plays very important, and how it is plays very important we will discuss in the next coming sessions. Okay, so what are the types of convection? One is called as a natural convection and other one is called as the forced convection here, that is. Okay, so you discuss that here. So natural convection or also we need to call that one is the pre-convection. Okay, natural convection or pre-convection here. In a natural convection, the fluid motion occurs by the naturally. Understand? The fluid will be flowing naturally. Suppose air. Okay, air, the moving, okay. So that one is how the air will be moving. As the temperature of the air increases, understand, as the temperature of the air increases, density of the air will be decreases, understand. So if the density of the air is increases, then the what is called as the movement of the air particles will be occurs, that one is, okay. One molecules, if the one molecules, that density of that molecule is decreases, it will displace us to the some other places. Immediately the next molecules occupies that place, understand. That is called as a movement. Like that movement of the molecules will be occurs in the air, means that is called as the naturally movement of the molecules, that is due to the density difference, okay, like that. So suppose that one is the suppose if you observe that one is the what is called as a water heater put into the a pot or vessel. So switch on the a water heater, then after some times you observe that bubbles will be moving up, okay. Why? Because of the, so you are supplying the heating to the water, so water particles get heated, then due to the increase in the temperature of the water particles, then automatically density of the particles will be decreases, that one is, understand. So if the temperature of the particles increases, density will be decreases. If the density will be decreases, automatically molecules of the water particles will be moving up. So they are called as the bubbles. Understand? So that is called as a best example of the natural convection. Understand? So that's why in the natural convection, fluid motion occurs by natural, that is due to density difference. That is due to density difference, means such as a buoyancy also. Understand? So we can call that one as a buoyancy, since fluid velocity associated with the natural convection is relatively low. Understand? Fluid velocity associated with the natural convection is relatively low. The heat transfer coefficient encountered in the natural convection is also low. What is the heat transfer coefficient? H, which is encountered, which is also coming to the picture in the natural convection, is also low. Understand? Okay. So that's the important point here. Okay. How the natural convection occurs? Natural convection, the type of the convection. So that means the heat transfer occurs in the fluid medium due to the density difference. Understand? Density difference. So that is called as a natural convection. That one is the fluid velocity associated with the natural convection is very low, hence the heat transfer coefficient encounter, which is related to the natural convection, is also very low here. Okay, so give an example here. Understand? So boiling or condensation process is also referred to as the convective heat transfer process here. Suppose that one is the here the example here, heated plate. Heated plate, that one is the cold air is coming, that is cold air, that one is, then warm air will be moving. Understand? Warm air. So cold air, so coming here, okay. So that means it will get the temperature. It will heat transfer from the what is called as the heated plate here. Understand? Then so it will be heat the what is called as the cold air, and cold air automatically the temperature of the cold air will be increases. If the temperature of the cold air will be increases, density of the what is called as the air will be decreases. Hence, displacement of the molecules of the air will be occurs from one portion to the another portions due to the decreases in the density of the air molecules here. Understand? Okay. So, but the best example that one is called as a boiling and condensation process, also referred to as a convective heat transfer process. Certain is understand? Okay. So I given that one is the vessel. Okay, putting the heater into the vessel, and so after some times you observe that one is the bubbles. So that is called as a natural convection. Understand? That is also called as a natural convection or free convection. Then what are the important parameters? Okay, we must know in the natural convection. One is called as the velocity. Okay, velocity associated with the natural convection is very less. Due to the velocity less, heat transfer coefficient which is encountered in the natural convection is also very low. Okay, if the heat transfer coefficient so is also very low, then heat transfer is also very less in the natural convection, that is because Q is directly proportional to the H, that is called as heat transfer coefficient, that one is. Understand? Okay, so these are the important parameters and important, that is the points in the natural convection, that is. Okay, so apart from this one is we need to discuss about that what are the important points in the natural convection or free convection. The convection heat transfer by the fluid, because fluid are not a good conductor. Understand? Convection so is a predominant in the liquid, because conduction is not a predominant in the liquid. Understand? So how the heat transfer will be taking place, that is in the what is called as the conduction. Understand? So what is called as the conduction, that so in the heat transfer in the fluid is by the convection. Okay, convection is the predominant here, that one is. Okay, a natural convection can only occur in the gravitational field. Understand? So natural convection occurs only in the gravitational field or in the presence of another proper acceleration. Because we need density difference. Understand? Because we need the density difference. So that's why natural convection can only occur in the gravitational field or in the presence of another proper acceleration, such as acceleration, centrifugal force, and Coriolis force. What is the meaning of the centrifugal force? You know that one is acceleration. You know what is the Coriolis force? That is called as the hurricane winds turning left in the northern hemisphere. So swirling action, which is in the ocean or which is in the northern hemisphere, that one is understand. So that is due to the highly temperature areas. So due to the temperature increases in that particular area, density will be density difference will be more. Understand? Okay. So density will be decreases in the particular area due to the temperature increase of the air. Then due to that one, so that one is the wind turning. Okay, wind turning will be taking place. That one is understand. So that is called as a natural convection. Whatever the heat transfer in that particular point, that is called as due to the natural convection, or due to that one is, we can call that as a density difference, that one is. Okay, so that's why so natural convection can only occur in the gravitational field or in the presence of another proper acceleration, such as acceleration, centrifugal force, or Coriolis force, hurricane, that is called as a hurricane winds turning left in the northern hemisphere. Okay. At the surface, I told that so taking the plate and heat transfer from the plate surface to the air fluid. Okay. At the surface, energy flow occurs purely by conduction. Understand? Suppose if we take the plate here, so that means at the surface, whatever the heat transfer or energy transfer at the surface is purely by conduction, even if the fluid is flowing on the fluid is there on the plate at the surface, so whatever the heat transfer or energy transfer, that is purely by conduction. Understand? So as the temperature of the fluid, understand, as the temperature of the fluid increases, density of the fluid decreases, hence the fluid movement occurs in natural convection certainties. Okay. Next one. So here heat transfer. Heat transfer rate much lesser than in the post convection. Okay, heat transfer rate much lesser than in the post convection. These are the important points in the natural convection. That is one is that already we discussed. Heat transfer rate is much lesser than in the post convection. So heat transfer in the natural convection occurs due to the density difference only, and at the surface whatever the heat transfer is purely by conduction. Okay, so then what is the post convection? So post convection is a special type of heat transfer in which fluids are forced to move in order to increase the heat transfer. Okay, in order to. So in the natural convection, what we discuss in the natural convection, the heat transfer is less. Okay, heat transfer is a less, but I want to more heat transfer, more convective heat transfer I require. So then, so we are not, so that one is the referring that one is a natural convection, then we have to go for the a post convection. Okay, what is the meaning of the post convection? Post convection is a special type of the heat transfer in which fluids are forced to move in order to increase the heat transfer. This forcing can be done with a ceiling fan, a pump, suction device, or other. You can observe that one is the blower. Okay, so blower in the fluid mechanics lab, you come to know about that one is what is the meaning of the blower. So blower in the furnace they are using. Understand? In the furnace they are using for the what is called as a post convection. That the blower transfer the what is called as the air. Okay, to move the air, to move the air means it gives the high velocity to the air. Understand? High velocity to the air here. Okay, so that is called as the means that one is the heat transfer. The post convection is called as a type of the convection heat transfer, in which case heat transfer occurs due to the external aid, that is called as the pump or suction devices or other the blower or other any other devices like fan or something that. Okay, so here convection is a complex heat transfer method. Remember that convection, as like the conduction and radiation, the convection is that one is not like that. Okay, so conduction is an easy process and radiation is an easy thing that one. But convection is a complex heat transfer method. Okay, but it can be expressed by so Newton's law of heating and cooling. Okay, this post convection is what is called as the governing law of the convection. Understand? So Newton's law of cooling is called as or heating or cooling are the so governing law of the convection. So this force convection is governed by the what is called as Newton's law of heating or cooling. So this is a complex method, okay? Force convection. Convection is itself is a complex method. Understand? Complex heat transfer method. So in that, force convection is still it is a complexion that one is as compared to the natural convection. Heat transfer coefficient is much more in the force convection, okay? But in the natural convection, heat transfer is less. Understand? Heat transfer coefficient is less. But in the post convection, heat transfer coefficient is much more in the post convection. Hence, the much heat transfer occurs during the post convection. Understand? Okay. So you can differentiate what is the meaning of the natural convection. What is the meaning of the what is called as a post convection? They may ask the questions like that. So what is the difference between the post convection and natural convection? First one, by the definitions, the convection, post convection, the type of the convection in which case the heat transfer will be occurs in the fluid medium due to the external agency like that is a pump, fan, or so any other devices like blower. So that is called as a post convection. Means that one is we are forcing the air to pass through the heated element, okay, to pass over the heated element, okay. So here, suppose if it is the plate here, understand, if it is the plate here, the fluid is flowing. Here at this side, any pan will be there, blower will be there. So blower forces the or pan forces the air or any liquid flow over the plate here. Understand? So in that cases, in such situation, whatever the heat transfer occurs, that is called as a post-convection heat transfer. That is. Understand? Heat transfer is much more as compared to the natural convection. Okay? And heat transfer coefficient is much more in the post-convection as compared to the natural convection here. That one is. Understand? So that one is the here in this case they are using the what is called as external agency here. That one is. Okay. Here. So what is the post convection? Okay. So this is diagrammatically represent here. That one is the post convection here. That is. Okay. Here the convection, the velocity V infinity here and temperature T infinity here. That is okay. So solid surface, solid hot. This one is called as the hot surface here. Understand? This one is called as the hot surfaces, and fluid is moving with the velocity V infinity over the plate here, and which having a temperature T infinity. And Ts, this Ts is called as a surface temperature. That is, and so at the surface, you can come to know about that one is at the surface. This the velocity at the surface is 0. Why? Because of the viscosity is more at the surface. I am right here. Sakir?
Yes, sir. Yes, sir.
Because at the surface, the velocity is 0. Understand? The velocity is 0 here because that one is the viscosity is the more here. That one is at the surface. Understand? So that's why we need to. So that one is the force the liquid. So that one is from the inlet to the outlet here. That one is. So for force the liquid, so what we are using, so that is called as a pan or blower. Understand? Pan or blower we are using. So that is in the case of the force convection here. Here it is assumed that. So what we discuss, understand? Okay. Here So solid hot surface Ts, and this one is called as the T infinity is the fluid temperature. Then Q is equal to H into A into dt. Okay. So what is the dt? dt is called as surface temperature. Understand? Surface temperature. What is surface temperature? Ts minus T infinity is called as a temperature gradient. That one is. Understand? So that is called as so this is the what is the diagrammatic representations of the post connection. Okay. Here that is so through this is the plate. Understand? Through plate conduction will be happening, and this is the fluid which is flowing over the plate. So convection will be happening here. Then the fluid is moving with the velocity v infinity. So and temperature T infinity, and so moving over the plate, hence that one is the how that one is the heat transfer taking place, that is due to the post convection. If the high velocity occurs, high heat transfer rate will be occurs. Okay, so that's why I am telling that one is Reynolds number is plays a very important role. What Reynolds number it indicates, whether it is the Reynolds number, significance of the Reynolds number is whether it is the flow is laminar or turbulent, that is. So turbulent means that one is high velocity. Laminar means that one is a low velocity. Okay, so here at the surface, zero velocity means viscosity will be very high at the surface. Hence, so we consider the conduction is a predominant at the what is called as at the surface of the plate. Why? Because of the viscosity is more at the surface and velocity is very less at the surface here. So this is called as the velocity profile. Understand? So this is called as the velocity profile. The velocity is maximum at the middle and velocity is equal to zero at the surface of the plate here. Understand? So that's why it is assumed that velocity of the fluid is zero at the wall. This assumption is called as a no slip conditions here. That one. Okay. So this is the post convection. Okay. Suppose it is other one is the diagrammatic representations of the post convection. So it is the post air. Okay. Post air. This is the pan, and this is called as the hot surface. So if you go and observe that, you can that here the temperature of the air here at here T1 temperature, and at the so this place T2 temperature, at this place this is the T3 temperature. Understand? So you can tell that the T3 is greater than the T2 and T1 temperature. Understand? Because that is the already it is passed over the hot surfaces, so automatically T3 will be maximum than the T2 and T3. If the more, understand, okay, if the more velocity of the air occurs, understand, the more heat transfer, much heat transfer will be occurs, that one is, understand. So that's what is the Reynolds number is plays very important in the post convection, that one is. Okay. Then, so convective heat transfer coefficient. Okay. Suppose that one is the, I asked the questions to the some of the people in the IIT zone and the NIT people on the faculty where we are in the discussion, that one is. Suppose the water is there. Water we can use for the post convection as well as the for the natural convection. Whether the heat transfer coefficient for the both it will be same or different patterns. Okay, heat transfer coefficient will be different. How? So how that one is? So convective heat transfer coefficient H strongly depends on the fluid properties. Remember that one is H is strongly depend on the fluid properties. What are the fluid properties? Density, dynamic viscosity, Prandtl number, okay? than thermal conductivity of the fluid. Understand? Okay. The convective heat transfer coefficient H strongly depend on the fluid properties and roughness of the solid surfaces that one is. Understand? Okay. So if the roughness is there, what happens? Whether the H is decreases or increases. Why? Because Q is directly proportional to the H here. You come to know about this equation. Q is directly proportional to the H. If the H is increases, understand, if the H is increases, heat transfer rate is increases, that one is. Understand? How H will be depend? H will be depending upon the fluid properties. What are the fluid properties? Density, viscosity, velocity, so and temperature and thermal conductivity of the fluid properties, that one is. Okay, if the water you are using, okay, as a fluid, which is for the convection purposes, the fluid properties of the water we need to consider, that one is we taken in the condensation and what is called as boiling already, that one is. Understand? So that's why H strongly depends on the fluid properties and roughness of the solid surfaces. If the surface is smooth, okay, then what about the H? If the surface is rough, then what about the what is called as that one is the H? Okay, already if the surface is rough, then nucleation of the boiling will be taking place. That is called as the important pattern and type of the fluid flow and the type of the fluid flow, that is. Okay, so that's a very important pattern is. Yes, Sakib, are you getting my voice?
Yeah, sir.
Yes, here going to the next one, that is a difference between the natural convection and post convection here. Okay, so what are the difference between the natural convection and post convection here? Okay, so already I discussed that definition. So in the natural convection, a method of heat transfer in which the motion of the fluid is influenced by natural means. Okay, a method of, in the natural convection, a method of heat transfer in which the motion of the fluid is influenced by the natural means. But in the post convection, a method of heat transfer in which the motion of the fluids is influenced by the external means, because we are using the pump, blower, fan to circulate the fluid in the post convection. Understand? Okay, but in the natural convection we are not using any pumps or any external air, okay, to circulate the fluid. That is, it is a stationary. In the natural convection the fluid is a stationary. In the post convection fluid is moving, okay, from one place to the other place, that is due to the by external means, that is called as a pump, blower or fan. Okay. So in the natural convection, what we discuss, I think you come to know that heat transfer is much more in the natural convection, understand? But in the in the natural convection, heat transfer is very less, understand? Heat transfer is very less as compared to the post convection, understand? Why? Because of that one is the H is more in the post convection. Understand? Okay? H is more in the post convection. In the post convection, heat transfer is just you write. In the natural convection, heat transfer is less. In the post convection, heat transfer is more here. That one is. Okay? And in the factor which is affect, that is a fluid motion, initiation of the fluid motion. Okay. Yes, Sakim, I'm getting my, you are getting
Yeah,
my
I'm getting your voice, sir. Yeah, yeah.
Yes. Initiation of the fluid motion. Okay. Fluid motion generates as a result of change of density. Okay. We discussed that it is fluid motion generates as a result of change of density of fluid when heated. But in the post-convection, fluid motion generates as a result of external sources such as a pumping, fan, suction, or devices. Okay, so this is the regarding the initiation of fluid motion. Okay, in the natural convection, fluid motion is due to the density, but in the post-convection, fluid motion is due to the fan or pump that is. Third difference is that factors affecting the heat transfer. No external factors affecting the heat transfer in case of natural convection. Okay? No external factors affect the heat transfer in case of the natural convection. But in the post-convection, only external factors can cause the heat transfer. What are the external factors? Velocity. Understand? Velocity is the external factor. Velocity of the fluid and surface. Okay. What is the surface? Roughness. Okay. How it is? That one is a smooth surface or rough surface. That one is only external factors can cause the heat transfer in the post convection, but there is no such type of external factors which affects the heat transfer in the natural convection that is. So this is the in the fourth point, that is called as an example, cooling down a boiled egg. Understand, cooling down the boiled egg when kept in the normal air, loss of cool drink. Okay, loss of that is a cool of a cool drink can. Understand? So that means the if we cool so cool drinks can that is understand. If we kept outside from the refrigeration, automatically that means what will happen? That is also natural convection. Understand? If you cool so A okay. So that means the if the boiled egg is there, if your boiled egg is kept outside, then automatically the cooling will be taking place. That is totally a natural convection. Understand? Okay. So, but in the post convection, air conditioning, steam turbine, okay, air conditioning system and steam turbine certain is are called as the post convection. Why? Because in the air conditioning and steam turbine, we are using that one is the external pump or blower or anything fan. So in order to cause the heat transfer in the post convection. Okay. So these are the examples of the natural convection and post convection here that one is. Okay. So these are the what is called as a natural convection and post convection here. And what is the difference between the natural convection and post convection? And what is the where the heat transfer occurs more in the natural convection or post convection? And why it is the heat transfer is more in the post convection and less in the natural convection. In the today's class we discuss about that. Okay, today